The search for potentially habitable planets is one of the most exciting and promising frontiers in modern science. The discovery of these exoplanets, worlds outside our solar system, could not only expand our understanding of the universe, but also open up the possibility of finding life beyond Earth. The search for potentially habitable planets revolves around several key factors, such as the presence of liquid water, suitable atmospheric conditions, and the ability of these planets to maintain temperatures that would allow for biological processes similar to those found on Earth. The study of these exoplanets has grown tremendously, aided by advancements in space telescopes, improved detection methods, and a deeper understanding of the factors that govern the habitability of a planet. At the core of this search is the concept of the habitable zone, often referred to as the Goldilocks zone. This zone is the region around a star where the temperature is just right for liquid water to exist on the surface of a planet. Not too hot to cause water to evaporate, and not too cold for it to freeze. The size of this habitable zone varies depending on the type of star, with stars similar to our Sun having a habitable zone at a greater distance than red dwarfs, which are cooler and less luminous. While the concept of the habitable zone is crucial, it is not the only factor in determining whether a planet is truly habitable. Other important aspects include the composition of the planet's atmosphere, the presence of a protective magnetic field, and its geological characteristics, all of which influence the planet's ability to sustain life. The search for exoplanets in the habitable zone has been made possible by several space missions and advanced detection techniques. One of the most significant missions was the Kepler Space Telescope. Launched in 2009, Kepler was designed to detect exoplanets by using the transit method, where it observed the slight dimming of a star's light as a planet passed in front of it. By measuring the amount of dimming and the timing of the transits, astronomers could infer the size, orbital period, and distance of the planet from its star. Kepler's observations led to the discovery of thousands of exoplanets, many of which lie within the habitable zone of their respective stars. The discovery of these planets opened new possibilities for finding Earth-like worlds in other star systems. Another important method for detecting exoplanets is the radial velocity technique, also known as the Doppler method. This technique involves measuring the gravitational influence of a planet on its host star, causing the star to wobble slightly in response to the planet's orbit. By analyzing the star's light spectrum, astronomers can detect these wobbles and calculate the planet's mass and orbit. This method has been particularly useful for detecting exoplanets that are too far from their stars to be detected by the transit method. It has been instrumental in identifying potentially habitable planets, especially those located in the outer reaches of the habitable zone. One of the key factors in determining the habitability of a planet is its size. In general, planets that are too large, like Jupiter or Saturn, are unlikely to have surfaces where life could thrive due to their massive atmospheres and lack of a solid surface. On the other hand, planets that are too small may lack the necessary gravity to retain an atmosphere, or may not have enough geological activity to support life. The best candidates for habitability are planets that are roughly similar in size to Earth, with a solid surface and an atmosphere capable of supporting liquid water. These Earth-like planets are often referred to as terrestrial planets or rocky planets. Some of the most promising candidates for potentially habitable planets include those found in the Kepler and TESS Transiting Exoplanet Survey satellite missions. One such planet is Proxima b, located in the habitable zone of the star Proxima Centauri, the closest known star to the Sun. Proxima b is roughly the same size as Earth and is in the right distance from its star for liquid water to potentially exist. However, Proxima Centauri is a red dwarf star, and red dwarfs are known for their frequent stellar flares, which could strip away the planet's atmosphere and make it difficult for life to thrive. Despite these challenges, Proxima b remains one of the most intriguing candidates for the search for life beyond our solar system. Another important discovery is Kepler 452b, often referred to as Earth's cousin. Located about 1,400 light-years away, Kepler 452b orbits a star that is very similar to the Sun and lies within the habitable zone. This planet is only slightly larger than Earth, and its location in the habitable zone makes it a prime candidate for further study. However, it is still uncertain whether Kepler 452b has the right atmospheric conditions to support life. Its discovery is particularly exciting because it suggests that there may be other planets in our galaxy that have conditions similar to Earth's, which could increase the chances of finding life elsewhere in the universe. Kepler 186f, located about 500 light-years away, is another potentially habitable exoplanet. It was the first Earth-sized planet discovered in the habitable zone of its star. While its host star is a red dwarf, which presents some challenges, Kepler 186f is still an interesting candidate because of its size and location in the habitable zone. Its discovery has fueled further interest in studying red dwarf stars, which are the most common type of star in our galaxy. Despite the challenges posed by red dwarfs, planets like Kepler 186f show that there is potential for habitable worlds around stars that are quite different from our Sun. One of the most exciting discoveries in the search for potentially habitable planets came with the TRAPPIST-1 system. Located just 39 light-years away, this system contains 7 Earth-sized planets, 3 of which lie within the habitable zone of their star. The TRAPPIST-1 planets are particularly interesting because they are located so close together, which allows for the possibility of studying them as a group. This system has become one of the prime targets for studying exoplanets, with the potential to support life. The discovery of the TRAPPIST-1 planets has sparked considerable interest in further exploration and study, particularly regarding their atmospheres and the potential for water to exist on their surfaces. In addition to these well-known exoplanets, there are numerous other potentially habitable planets that have been discovered. LHS 1000-140b, located 40 light-years away, is another exciting candidate. It is a rocky planet about 1.4 times the size of Earth and is located in the habitable zone of its star. LHS 1000-140b is particularly interesting because it is thought to have a thick atmosphere, which could provide the necessary conditions for liquid water to exist on its surface. This planet is an excellent target for future atmospheric studies, as its relatively close distance makes it a prime candidate for detailed observation. Despite these exciting discoveries, there are still many challenges in the search for truly habitable planets. One of the most significant challenges is the fact that we have limited knowledge of the specific conditions required for life. While scientists often look for Earth-like conditions, there may be forms of life that exist in environments vastly different from our own. This means that the search for habitable planets is not limited to those that resemble Earth in every way, but may also include planets with radically different characteristics, such as those with extreme temperatures, unusual atmospheric compositions, or even different solvents for life. Another challenge is the difficulty of studying exoplanets in detail. While we can detect the presence of exoplanets through various methods, such as measuring their transit or analyzing the light from their host stars, it is much harder to learn about the conditions on the surface of these planets. Future missions, such as the James Webb Space Telescope, which is scheduled for launch in the coming years, will help provide more detailed observations of exoplanet atmospheres, potentially allowing us to detect signs of life or conditions that could support it. In the future, the search for potentially habitable planets will likely continue to focus on exoplanets in the habitable zone of stars similar to our Sun. However, the discovery of planets in the habitable zone of red dwarf stars, as well as those orbiting other types of stars, will continue to be a significant part of the search. Advances in detection techniques such as direct imaging and atmospheric analysis will allow scientists to study exoplanets in greater detail and may eventually provide answers to the age-old question of whether life exists elsewhere in the universe. The discovery of potentially habitable planets marks a new chapter in our exploration of the cosmos, and it is a field of research that promises to uncover many exciting and potentially life-changing discoveries in the years to come.